Have you ever seen the sky ablaze with color? Imagine shimmering curtains of green, blue, and red dancing across the night. This is the Aurora Borealis, more commonly known as the Northern Lights. This breathtaking spectacle is not magic, but a captivating display of nature's power, a celestial ballet orchestrated by our sun and Earth's atmosphere. For centuries, the Northern Lights have captivated humanity, sparking curiosity and wonder. In this essay, we'll embark on a journey to understand the science behind this mesmerizing phenomenon. We'll explore the role of the solar wind, Earth's magnetic field, and the interaction of particles that paint the sky with such vibrant hues. Prepare to be amazed as we delve into the world of auroras where science and beauty collide. So, let's begin our exploration. Our sun is a star, a giant ball of hot gas that's constantly buzzing with activity. It's not just light and heat that the sun showers upon us. The sun also emits a constant stream of charged particles, a sort of solar wind that blows through our solar system at incredible speeds. Imagine a cosmic breeze carrying tiny particles like electrons and protons. This solar wind is constantly flowing outward from the sun, reaching far beyond the orbits of even the outermost planets. While invisible to the naked eye, this solar wind plays a crucial role in the captivating phenomenon we know as the Northern Lights. In the next section, we will see how this solar wind interacts with our planet to create the mesmerizing auroras. Buckle up as our journey through the cosmos continues. Our planet isn't just a passive recipient of the sun's energy, it has defenses. One of its most important lines of defense is its magnetic field. Picture Earth with a giant bar magnet inside, its invisible lines of force reaching far out into space. This is our planet's magnetosphere, a protective bubble that shields us from the constant barrage of the solar wind. When the solar wind, carrying its charged particles, encounters Earth's magnetic field, something fascinating happens. The magnetic field acts like a shield, deflecting most of the solar wind around our planet. This is crucial for life on Earth because the solar wind can be harmful. However, the story doesn't end there. While most of the solar wind is deflected, some particles manage to sneak in, especially near the Earth's poles. This is where the magic of the aurora begins. Now let's talk about the stars of the show, the colors of the aurora. Imagine the solar wind particles having sneaked past Earth's magnetic defenses, colliding with atoms in our atmosphere. It's like a cosmic game of billiards, with energy being transferred and light being emitted. The Earth's atmosphere is made up of different gases, primarily nitrogen and oxygen. When the charged particles from the solar wind collide with these gases, they transfer some of their energy. This energizes the atoms in the atmosphere, causing them to release light. The color of the light depends on which gas is being energized and how much energy it receives. Green, the most common auroral color, is produced by oxygen at lower altitudes. Higher up, oxygen can also produce red light. Excited nitrogen molecules create blue and purple hues, adding to the spectacular display. It's a breathtaking example of how the cosmos and our atmosphere collaborate to create a symphony of colors. Section 5. Where and when catching the Northern Lights. So, you're captivated by the aurora and want to witness this celestial ballet for yourself? The good news is that with a little planning and a dash of luck, you can increase your chances of seeing the Northern Lights. First, location is key. The auroras occur near Earth's magnetic poles, so your best bet is to head north, way north. Countries like Canada, Alaska, Iceland, Norway, Sweden, and Finland are prime aurora viewing territory. Second, timing is crucial. The winter months with their long, dark nights offer the best viewing opportunities. Clear skies are essential, so keep an eye on the weather forecast. And finally, escape the city lights. Light pollution can drown out the delicate glow of the aurora. Find a dark, secluded spot for optimal viewing. Section 6. Legends and Lore, Ancient Tales of the Aurora. The Northern Lights have captivated humans for millennia, long before we understood the science behind their ethereal glow. Ancient cultures witnessing the celestial display dancing across the sky wove tales and legends to explain this mesmerizing phenomenon. In Norse mythology, the Aurora Borealis was said to be the shimmering armor of the Valkyries, female figures who decided who would live or die in battle as they rode across the sky. The Inuit people of Greenland believed the aurora to be the spirits of their ancestors playing a game with a walrus skull in the heavens. These stories, passed down through generations, illustrate the profound impact the Northern Lights have had on human imagination. They remind us that the beauty of the natural world has always inspired awe and wonder. Section 7. The science of prediction forecasting auroral activity. While the aurora is a natural phenomenon, and therefore somewhat unpredictable, scientists have made significant strides in forecasting auroral activity. Just like we have weather forecasts, there are now space weather forecasts that can give us a heads up about when and where the northern lights might make an appearance. Scientists monitor the sun's activity, particularly solar flares and coronal mass ejections, which release huge bursts of energy and charged particles into space. These solar storms can amplify the solar wind, increasing the likelihood of auroral displays on Earth. Websites and apps dedicated to aurora forecasting use data from satellites and ground-based observatories to provide real-time updates and predictions. This information can be invaluable for aurora chasers hoping to witness this celestial spectacle. Section 8. Southern Lights, Aurora Australis. While the northern lights, or Aurora Borealis, steal much of the limelight, our planet boasts a second auroral marvel, the Aurora Australis, or Southern Lights. Just like their northern counterpart, the southern lights occur when charged particles from the sun interact with Earth's atmosphere near the South Pole. The southern lights are visible in regions surrounding Antarctica, including the southern tips of South America, Australia, and New Zealand. While less accessible than the northern lights, the southern lights offer an equally mesmerizing display of dancing lights and vibrant colors. Imagine standing on the icy plains of Antarctica, gazing up at the celestial ballet of the southern lights. It's a reminder that nature's grand spectacles are not confined to one hemisphere, but grace our planet in both its northern and southern reaches. Section 9. Auroras beyond Earth, celestial wonders across the solar system. Auroras are not unique to Earth. In fact, these dazzling displays of light have been observed on other planets in our solar system and even beyond. The presence of auroras is a telltale sign that a planet or moon has a magnetic field and an atmosphere, two ingredients necessary for this celestial ballet to unfold. Jupiter, the largest planet in our solar system, boasts the most powerful auroras. Its intense magnetic field and its moon Io, which spews volcanic material into space, contribute to spectacular auroral displays that dwarf those on Earth. Saturn, Uranus, and Neptune have also been observed to have auroras. Even Mars, with its thin atmosphere, shows evidence of auroral activity. These discoveries highlight that the universe is full of wonder, and that the celestial phenomena we observe on Earth have counterparts in the vast expanse of space. Section 10. The allure of the aurora, a source of inspiration and awe. The northern lights have captivated humans for centuries, inspiring art, music, and literature. Their ethereal beauty evokes a sense of wonder and awe, reminding us of the vastness and mystery of the universe we inhabit. Artists have attempted to capture the aurora's ephemeral beauty on canvas, using brushstrokes to mimic the dancing lights and shimmering colors. Composers have been moved by their ethereal glow, translating the celestial symphony into music that stirs the soul. Poets have penned verses celebrating their wonder, using words to paint pictures of the night sky ablaze with color. The allure of the aurora lies not only in its visual splendor but also in its reminder of our place in the cosmos. As we gaze up at the celestial ballet unfolding above, we are reminded of the interconnectedness of our planet, our sun, and the vast universe beyond. Section 11. Conclusion, a final thought. As our exploration of the northern lights draws to a close, we're left with a sense of awe and appreciation for the wonders of the natural world. We've journeyed from the fiery heart of our sun, following the solar wind on its journey through space, to witness its encounter with Earth's magnetic field and atmosphere. We've delved into the science behind the captivating colors of the aurora, exploring the interactions of charged particles and atmospheric gases that paint the night sky with such vibrancy. The northern lights, a celestial ballet orchestrated by the sun and earth, stand as a testament to the beauty and power of nature. They remind us that there is still much to discover and explore in the universe we inhabit. So, keep looking up at the night sky. You never know what wonders await.